Algebra 1. So we're actually going to go ahead, we're going to be talking about two sections today. We're going to talk about 3.1, which is all about functions. And we're going to jump a little bit to 3.3, which is function notation, meaning how you write functions. So definitely going to go ahead and talk about both of those today. But before we talk about functions, we need to talk a little bit about a thing called relations. And it's exactly what you think, right? It is two things that are paired together. It's kind of like a relationship, right? So relations. And when math, we talk about it in terms of inputs and outputs. For example, a coordinate plane has inputs of x and outputs of y. You're going to see this a lot today. So these are the inputs, and y are the outputs, meaning the number that you get out after you put a number in. And an example of this, or of a relation, might be something like the amount of donuts you can eat and your birth month. So I'm actually going to say birth month for input. Birth month, so January, February, March, April, May. And these are the donuts that you can eat. So the amount of donuts that you can eat. So 1, 2, 3, 4. So we're going to go ahead, we're going to walk down the street a little bit, and we're going to run into somebody born in February. And we ask them, hey, how many donuts can you eat? And they say, I can eat 3 donuts. So they have an input of February and output of 3. 2, 3. Then we keep walking down the street and we say, hey, what month were you born in? And they say, April, and I can eat 1 donut. So 4, 1 is our input and output relation. And we keep walking down the street, we keep asking people. We have someone in January who can eat 2, somebody in February again, but this time they eat 1, somebody in March that can eat 4, somebody in March again that can eat 2, all right, and somebody in April one more time, and they can also eat 4. All right, so this is what's called a relation, right? We're talking about birth month and donuts. And if you'll notice here, when we went to people in February, we had 2 possibilities. They could either eat 1 donut or they could eat 3 donuts. Same thing with March, is that we had 2 possibilities, 2 donuts or 4 donuts, and April, 1 donut or 4 donuts, is that there were 2 possibilities for every input. Which brings us to our functions. So really key in here if you were spacing out functions. And functions are a certain type of relation. So a function is a relation that pairs each input with exactly, and underline exactly, 1 output. So a function is a relation that pairs each input with exactly 1 output. So our example for this one might be something like the money that you spent. So money that you spent and the donuts you bought. I'm going to say bought for this one. Donuts you bought. And I'll say 1, 2, 3, 4. And the money that you spent here is $1, $2, $3, $4, $5, $6. Okay. So let's just say that it's an expensive place. It's Johnny Donuts. So it's like $2 a donut, meaning that if I spend $2, I'm going to get 1 donut. And every time I spend $2, I'd get 1 donut. I would never get a different amount of donuts there. And if I spend $4, I get 2 donuts. If I spend $6, I get 3 donuts. And I'm always going to get the exact output for every input on this one. So always having exactly, I'm going to go ahead, I'm even going to highlight this, exactly one output for every input. Another way to think about this is that you always know what you're going to get out. So I always like to go ahead, I like to use the example of a vending machine. And I like to use the example of a vending machine because whenever you go ahead and you press A1, you're going to get a water or whatever is in the A1 slot. If you go ahead and you hit, I don't know, D3, you're going to get your Snickers or whatever's in that D3. You always get exactly whatever you put in. There's never a time where you press A1 and you might get a water or you might get a Snickers. You just don't know. So you always know exactly what you're going to go ahead and get out. Another example that I like to use, and I'm going to switch colors for this one, go to our peach. Example of our function, and one of my favorites, is when you go ahead and you put bread into a toaster. All right, and whenever you put bread into the toaster, you're always going to go ahead, you're going to get toast out of that. Bread into the toaster, you're going to get toast. There's never a time where you would put bread into a toaster and get, I don't know, a shoe out. You would never get anything out besides toast. So you could go ahead and cross off this section right here, right? It's not true. And this toaster, what we refer to in math, is kind of the function machine. It's the machine, or what we're doing in order to get an output, kind of like a vending machine. And this is where it gets into our math section. So, we've already used blue. We'll go to green for this one. So when we talk about functions in terms of math, so I'm going to say math functions. You might have seen these before, right? And in terms of a math function, we're going to go ahead, we're going to input a number, and our function machine to it is that we are going to double that number, so double and add 5. So that's what we're going to do with our machine. So we're going to double it and then add 5. And then once we do that to the number, we would get our output or our new number, right? So we would also know this as input a number, aka x. And then we're going to double and add 5 and get an output, aka y. So you guys might be used to seeing this such as y is equal to double 2x plus 5, right? 2x plus 5, I'm going to put this up here. So you might have seen that before where y ends up being your output and x is your input. And this is where section 3.3 comes in, because now we have this thing called function notation. And function notation says f of x, we kind of write it in this funky little way, f parentheses, x close parentheses, is equal to, and then you just write whatever your function is, 2x plus 5. And this is this function notation. And all you do on your function notation is you're just kind of replacing y with this f of x. I'm going to keep saying that, f of x, because it's not f times x, it's f of x. And you might be saying, Ms. Lawrence, why the heck are we using it like this? Well, there actually is a point to it. And that's because when we write our function notation, for example, if we're using this function, I'm going to rewrite it for you. F of x is equal to 2x plus 5. We might say something like f of 6. And whatever is inside your parentheses here. So whatever is inside your parentheses, you replace it on with your x there. So we're going to say 2 times 6 plus 5. And you guys, of course, can do this in your head. 2 times 6 is 12. 12 plus 5 is 17. So how we actually write this is f of 6 is equal to 5. Meaning that when my input is 6, my output is going to be 5. Not 6. 5. And this notation right here shows you your input and output. Now we can also put this as a coordinate point. So we could say, well, this is the point 6. Oops, not 5. It's 17. Silly Miss Lawrence. I was using the wrong one. 6. $17. Sorry, y'all. Hopefully you put that correctly on your notes. Okay, for this next one, now you're going to understand why I was writing 5. So we might say something like f of 0, meaning that we would say f of 0 is equal to 2 times 0 plus 5. 2 times 0 is 0 plus 5. F of 0 is equal to 5, meaning that this is the point 0, 5. When my input is 0, my output is 5. And let's try this one more time here. So we would have f of negative 3. Hopefully you're saying this with me. F of negative 3. 2 times negative 3 plus 5. Again, you guys can all do this in your head. F of negative 3. Negative 6 plus 5 is negative 1. This is the point negative 3, negative 1. And that's how we kind of use this funky function notation, is again, it tells you your input and your output. So just as a reminder on your function notation, let's use a darker blue here, is that whatever goes inside those parentheses is what you put in your function. So I might have something like f of x is equal to x squared plus 3x minus 6. And if I want to say, well, what is f of smiley face? You just go ahead and you insert smiley face into your equation, 3 times smiley face, wherever that x is. So this would be smiley face squared plus 3 times smiley face minus 6. Or what about f of stickman? F of stickman is going to be stickman squared plus 3 times stickman minus 6. So whatever's inside those parentheses, you input it there. Now in terms of numbers, all right, let's go ahead, let's do the math one. F of 2 is equal to 2 squared plus 3 times 2 minus 6. Now we can go ahead and simplify this a little bit more, meaning that f of 2 is equal to 4, and we have plus 6 minus 6. F of 2 is equal to 4, meaning I have the input of 2 and the output of 4. All right, great job, Algebra 1. Functions and functions notation are tough, and you hung in there. Great job.